When we add and subtract complex numbers, we pretty much treat these as problems where we're adding like terms. Our real numbers, our real parts of the complex number are going to be like terms, and our imaginary numbers are going to be like terms. So for example, in the complex number 8 minus 1i, 8 is my real number. In the complex number 5 plus 4i, 5 is the real number. So adding those real numbers together, I get 13. And then also let's match up our imaginary numbers. So negative 1i plus 4i adds up to 3i. That is my answer. It's as easy as that. Just add up the real numbers and add up the imaginary numbers, and there you go. When you're subtracting, same idea. I don't like subtracting, so I'm going to change the subtraction sign to a plus, a negative 2. That's also going to help me remember that I'm distributing a negative 2 into this parenthesis, so both terms are going to change signs. So negative 2 times 3 is just negative 6. And then negative 2 times negative 6i is positive 12i. I is pretty much going to behave like a variable for this part. Once again, adding up my like terms, my real numbers are 7 and negative 6. Those add up to 1. And my imaginary numbers are negative 6i and positive 12i, and those add up to 6i. Multiplying with complex numbers is almost as simple. We, again, just kind of treat the I as a variable. The one big difference is we want to remember that I squared is equal to negative 1. So we never leave powers of I on our paper. If we ever have I squared, a pair of i's, we take the pair of i's out and replace them with a negative 1. That's the only real difference when multiplying. So first example, I'll just go ahead and distribute. So 4i times negative 6 is negative 24i. And that's just fine. And then 4i times positive I is positive 4i squared. Now, this is where I do have one more step to do. Remembering that I squared is equal to negative 1, I always want to replace that. I want to change that on my paper. So I squared is negative 1. And the rest is fine, and I by itself is just fine. So 4 times negative 1 is negative 4. Usually we'll write the real numbers in front. We don't have to, but usually we'll write the real part in front. So negative 4 minus 24i should be my solution. Now some people notice a shortcut right away, and they notice that all the I squared does is change signs. So when they see 4i plus 4i squared, they just cross it out and put a minus 4 in its place. Every I squared is just a sign change. Okay, and then next up, last on this screen, we have two binomials we want to multiply together. So if you like FOIL or distributive method, or distributive property, you can do that. I like the box method, so I'm going to stick with using that for multiplication. Just like we did with x's, binomials with just regular variables in them, I'm going to treat the complex numbers the same way. So write what I'm multiplying on the outside, and then go ahead and multiply rows and columns together to fill the box out. So 9 times negative 4 is negative 36. I get a positive 8i. A positive 63i, and then finally I have a negative 14i squared. Now once again, we never want to leave pairs of i's on our paper, so because we have an I squared, it's really equal to negative 1, so that last box is really negative 14, times negative 1, well you know what I meant, negative 14 times negative 1, or just positive 14, or like I said, my shortcut that I like to use, just cross it out and change the sign and drop the I squared, so it's a positive 14. Pulling all those numbers out of the box and adding up my real numbers, negative 36 plus 14 adds up to a negative 22. We usually like to put the real number in front, and then adding up my imaginary numbers, 63i plus 8i gets me a positive 71i. Last up, let's take a look at how to divide with complex numbers. Now our rule is similar to what we had with square roots in that we don't want to have i's, just like we didn't want to have square roots, on the bottom of a fraction. So there are a couple ways we can take a look at how to do these to get rid of that I. So if our denominator is a single term, like this 2i problem, all I need to do is multiply the top and the bottom, remember because that's just equal to 1, by I. Let's take a look at why that works. We'll do this one by hand. The next one we'll start by hand, but then we're going to switch over and actually use the calculator to finish this. I'll show you how to do these problems on your calculator. So single term multiplied just by a single I. Keeping this in parentheses, and remember that I'm distributing, my numerator is going to become negative 5i, and then plus I squared. My denominator is going to become 2i times I, which is 2i squared. Now, I had said at the beginning when we started this, our goal was to get rid of the i's in the bottom. And look, we have more i's in the bottom. Oh no. But hopefully you guys are thinking along the right track and realizing that I squared, it's okay to have that because I squared is just equal to negative 1. So my denominator is just going to become a negative 2 because 2 times negative 1 is negative 2. Similar in the top, I squared is just equal to -1, so let me just change that. So that's why multiplying by just an I will work. We want to make a pair of I's, which gets rid of it because it becomes a -1. So rearranging things a little bit, I'm going to rewrite my numerator with the real number in front. So -1 minus 5I divided by -2. Now, there's one more thing we need to do with the division problems, and that's write it in standard form. Standard form means we have two fractions, basically. I want to be able to point to this answer and say, look, here's the real fraction, and look, here's the imaginary fraction. And so what we're going to do, and this is what a lot of people forget if they're doing these by hand, is that we want to split the problems into two separate fractions. This is mandatory to do these correctly. So what I mean by splitting it is, let's write our real fraction. It's -1 divided by -2. The imaginary fraction is then -5I divided by -2, and I'll put a plus sign in between there. And now that they're split, I can simplify like I'd simplify any fraction. Two negatives would become a positive, so I get a positive 1/2. Same with my imaginary fraction. I get 5/2, and I like to put the I on the side. The I can either be on the side or in the numerator, just don't put it in the bottom. So there's my answer in simplified or in standard form, and I do need to make sure I split that. Okay, let's take a look at this last problem. We'll start it by hand just so I can show you how the process would work, but then I'm going to switch over and show you how to finish this on the calculator. So this time I do not just have a single term, I have a binomial in the bottom. What I'm going to do, again, thinking back to square roots, is I want to multiply by the conjugate. The conjugate, recall, is to take your expression, which is 1 minus 4i in the denominator, and just change the sign in the middle. So my conjugate is 1 plus 4i. I will multiply the top and the bottom by the same thing, because really all I'm doing is multiplying by 1 when I do this. That's going to be the trick to get rid of the I in the bottom of these problems that have binomials. I'll want to put both in parentheses, and here's where I'm going to stop doing the problem by hand. It's doable. It's just two box method problems in one. I need to multiply the two denominators together, and because I chose the conjugate, the I should cross out. And then I'll have to multiply the two numerators together, and remember to simplify by writing in standard form. It's totally doable. I want to finish this one up using the calculator to show you how to do that. If you want to try it by hand, go for it. Otherwise, let's see how to do that in the calculator.